On today's session, we are going to see about the stream and block ciphers. Okay, it is the two ways to build the symmetric encryption. So we already saw that it has the same goal. Okay, so it is symmetric encryption, and the methodology is different, but it is the symmetric encryption. So it uses one shared key for both encryption and decryption. The core difference is it in how the data is processed. Okay, so in stream cipher, that transforms a continuous key stream one bit or byte at a time, combining it directly into with a plain text. Okay, so goal is ciphertext look unrelated to plain text. Okay, in block cipher, we can see it transforms the fixed size block of data through repeated keyed mathematical rounds. Okay, so it makes ciphertext look unrelated to plain text. Both the goals are same since it is the symmetric method. Both the goals are same. So what is the question is, it is a continuous flow or discrete blocks. We can see in the coming video what it is about, it whether it is a continuous flow or discrete blocks. So what is stream cipher? It turns a key into a key stream. So this is how we convert it into the ciphertext. Ciphertext it is got by XORing the plain text along with the key stream. So a synchronized key stream is generated from a secret key, a nonce, and a counter or state. Decryption applies the exact same XOR operation. So in decryption we can see the plain text comes this side and the ciphertext goes that side, okay, along with the same key stream. Okay, so there will be same key stream, but the plain text comes this side to the left side and ciphertext goes to the right side. Okay, what are the strengths of the stream cipher? So first is a natural for continuous and variable length data streams. There will be no padding. And since the plain text and ciphertext length it will be equal. Okay, so there will be no padding, and the errors generally stay localized to the affected portion of the string. Okay, so what is the example is chacha. Okay, chacha 20 generates a high speed key stream, okay, as specified in RFC 8439. These are all the methodologies. Okay, it uses the 256 bit key and 96 bit nonce. Okay, what is the nonce we can see in the further video. So first problem is stream cipher. Encrypt plain text 1011 using the key 1100 with XOR operation. So when we are doing the XOR operation, 1011 is the plain text as we see before, and the next one is key is 110. So when we are taking the XOR operation, the same digits will be made to 0 and the different digits will be made to 1. So okay, so 10 is 1 and 10 is 1 and 01 is 1 and 11 is 0. Okay, so the ciphertext is 0 111 Okay, so this is the example. Okay, same digits, same, either both are same, 0 and 1 it is 0. Okay, so different digits it will give us 1. Okay, this is the XOR operation. So based on this XOR operation we have performed the stream cipher bit. Okay, one by one we are making it as one by one we are making it. Okay, this is the concept. Next is block ciphers. Okay, so the block ciphers is the fixed size of blocks. We will transform to the fixed size of block. A block cipher, it maps one fixed length plain text block to one ciphertext block using the secret key. Okay, so the major example for the block cipher is AES. AES 128 advanced encryption system. Okay, AES is advanced encryption system. AES 128, 192 and 256 all use 128 bit blocks. Okay, the numerical suffix identifies the key length. Okay, the suffix is there, right? So it will indicate the key length. Okay, so a mode of operation explains how to encrypt the messages longer than one block. Okay, so we are making it as multiple blocks. So think of AES as the engine. The model is modus in the transmission. So the transmission determines how the engine's power is applied to the road. Okay, so if AES is an engine, it is based on the mode of the transmission. So based on the key concepts it will transmit. Okay, so how, a simple example for the block cipher, how it uses the 4-bit block sizes. Okay, so 4-bit block sizes is, you can take it as this as the plain text. Okay, so we have said it is 4-bit block size. Okay, so we have to divide it into the 4-bit. So 1 0 1 1 and we are block making it as a block. Okay, 4 bit, since it is the 4 bit it is making us made as the 4-bit block size, and next is 0 double 1 0. Okay, next block. So we have made it into two blocks. Okay, so each block is encrypted as a unit or single unit. So there are two blocks. Okay, a block cipher needs a mode to encrypt a real message. Okay, so it defines 5 confidentiality modes for underlying block cipher. Here are the practical examples like a case study. Okay, so ECB encrypts each block independently. So it repeated plain text block reveal repeated ciphertext pattern. It is not recommended for general use. So CBC is cipher block chaining. So these chain blocks together so identical plain text yield cipher text. So it requires careful initialization vector handling. So this comes under the vector. So it is somewhat good for the general use. Okay. So next is counter. It turns a block cipher into key stream like construction by encrypting successive counter values, and it is highly based on the next methods. And Gallios or counter mode. Modern designs pair counter style encryption with authentication, and it provides both confidentiality and integrity. Finally, there is a comparison between the stream cipher and block cipher. So in stream cipher, how it is processed is bits or bytes, and in block cipher, it is based on the fixed size blocks. And next is padding. Padding, it is usually unnecessary because the same length of keyword and the plain text is taken. In block cipher, it may be needed because if we split it into 4 bits, if there is another bit is there, we need padding for 4 bit. Okay. So for example, if we take 0, 0, 0, 0, 1 and 1, and I am taking the 4 bit. Okay. So when I am taking 4 bit, you can split it as 1, 0, 0, 0. Okay. And the next one has only 0 and 1. Okay. So when I am splitting it, I have to pad it with the zeros. Okay. So there may be padding in the block cipher. And next one is the shape. Okay, the key stream plus XOR we can see. Okay, when we are converting it to the ciphertext, and here is key permutation plus the mode. How what mode is chosen? Common example is Cha-Cha 20, and here the block cipher is AES. The main operational risk is key stream or nonce reuse. We are using the same key at the sender and the receiver side for both encryption and decryption. And this has the unsafe mode or using the interrupt vector. We are using the interrupt vector and nonce reuse. So nonce is this number of occurrences. Okay, number of occurrences for the keyword. Okay, keyword. We are using the keyword again and again. So the security depends on algorithm, mode, implementation, key management, and nonce discipline, not the label, not the label alone. Okay, so which is better for based on the application, we have to choose the stream cipher or block cipher. Thank you for attending this session. Have a good day.